In this video, we're going to go over exponential smoothing. It's a forecasting method for data that has level but not seasonality or trend. So let's first review what we've done so far. Using the original stock data for the American Airlines or another stock that you chose, we took that and we created a summary table. We started by getting the moving average forecast. We used the data analysis toolpack, and we also learned how to do it using formulas. Then in the next video, we created a weighting moving average by setting our weights and multiplying the average close price for the period times the weight, adding those together and dividing it by the sum of the weights. We learned how to calculate the mean absolute deviation, and we used the Excel solver tool to try to create the solution that would have the least mean absolute deviation based on these weights that we selected. Just to refresh, in the last video I discussed that we have one numerical month for each year, and our data goes from 2013 to 2018. March of 2018 to December of 2018 are the future of this data set. You can see that I already have the exponential smoothing model set up here, but we're going to go through how we did it, and I'm going to do it fresh on a new tab. So first I'm going to take the year, month, period, and average close price columns, and I'm going to select all this data using the Control-Shift-Down key, and I'm going to copy it. On a new tab, I'm going to value paste it into A5. I'm using the value paste, which pastes only the values and not the formatting or the formulas. Now I'll just apply a little bit of formatting. We're also going to need to set an alpha cell. I'm going to start with the alpha of 0.2. Keep in mind that your alpha value needs to be between 0 and 1. Also recall that March of 2018 and onward were the future of the data set, so I'm going to delete those values. Before we proceed further, we'll just quickly review the forecast formula here. The exponential smoothing method is a method that's very similar to the weighted average, except that the exponential smoother decays in the past exponentially. We went over the math in a little bit more detail in class, but the important thing to remember for setting it up in Excel is this part here. The forecast of the time period t plus 1 equals the forecast of the time period t plus the alpha times the error of time t. The error of time t is calculated as the actual value for the forecast, or the actual value of time t minus the forecast value of time t. Now that we reviewed that concept, let's make a forecast column. To begin, we're going to set the first or the second period in our data set equal to the previous period. To calculate the next forecast, we're going to have to calculate the error. So let's make a column for error. Remember that error equals the actual minus the forecast. Now we have an error calculated for this forecast. Now we can set up the exponential smoothing. So this is going to be equal to the previous forecast plus the alpha we're going to need an absolute cell reference here, so I'm going to use F4. In some keyboards, it's FN plus F4. If you still have trouble, you can add those dollar signs manually. And we're going to multiply the alpha times the error from the previous period, and then press enter. We can then fill down the error from the previous period. Then we can select both and fill them all down until the end of our data set. We can fill our forecast down once more. In order to extend our forecast further, we're going to have to set our actual equal to our forecasted value. And just like in the last video, I'm going to shade this to show that it's not an actual value. We can copy those down, and we're not going to copy the error down. We're going to leave the error like that. This will also create the effect of flattening out our forecast, just like it did in the weighted moving average. So let's see how this looks on a chart. I'll select all the data. I did that by selecting the first two column headers and using Control-Shift down. And then on the Insert ribbon, a line chart. Now we can see how changing alpha affects our forecasts. Let's try 0.1. Let's try 0. You can see it looks very much exactly the same at 0, only it's the same data one step ahead. On the other extreme, close to 1 creates a lot of noise, as it only considers the most previous. Let's try a more industry level, which would be 0.2 to 0.3, and we could go around and test different levels to see how it affects the forecast, and we can also try to optimize the forecast. Since we already have an error column, let's use mean square error, and so we will make an error squared column, and now we can square the error by raising it to the second power, and we can fill down. I want to make sure I don't include areas where we don't actually have error. And let's set up a mean square error cell. We can use the average function of our error, and it's giving us a mean square error of 8.45. Next, we can go to our solver and see if we can optimize this. So we want to set the objective cell to G2 in this case, or wherever your mean square error is, and we would like to minimize it by changing the alpha cell. Now, the alpha must be between 0 and 1, and we have it set to make unconstrained variables non-negative, but we're going to have to add one constraint to make it not exceed the value of 1. Okay, now I have it set so that we want to change cell C2, subject to this constraint that C2 is less than or equal to 1. We want to make unconstrained variables non-negative, and we are setting the objective cell, which contains the mean squared error. Let's solve. Solver found a solution, and it suggests an alpha of 0.4162. I'll go ahead and keep the solver solution. And that's how you set up exponential smoothing forecasts in Excel.